In the previous lesson, we looked at the concept of similar and what it means in terms of polygons and circles. So what we're going to do in this lesson is we're going to take a look at similar triangles and what makes them similar and how we can tell if they are similar. So before we get working on the lesson, I would like for you to work on the warm-up and see if you can answer the question. And so pause the video, and then when you unpause it, we will go over it. So the question is, how are similar figures different from congruent figures? So congruent figures, remember, are same exact size and shape. Okay, so that means that the angles are the exact same size. That means that the lengths of the sides are the exact same size. But with similar figures, the difference is that the angles are congruent, but the sides don't need to be congruent. The sides are, instead of being congruent, sides are, remember, proportional. So that means that, they aren't necessarily the exact same size. So again, you'll see what I have highlighted here. You must know about both the angles and the sides of two quadrilaterals in order to make a valid conclusion about their similarity. So you need to know that the sides are proportional. And remember, an example of that would be if we had a polygon over here where the angles are all the same, and then you had like, let's say this is a parallelogram, you have 2, 2, and 4, 4, and then over here you have a slightly smaller parallelogram where the angles are all the same as this side, or this angle, or this parallelogram over here. So that's parallel or congruent to that. That's congruent to that, and so forth. And then the sides are, proportional to each other. So let's say this is 2 and 1, then this would be 4 and 2. So you have the sizes of the sides of the polygon are proportional. So remember, we talked about that there's shortcuts for finding triangle congruences. Triangle congruences, we had side, 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 angle, side, angle, side, angle, and side, angle, angle. And what we're going to look at in this lesson is, are there shortcuts for triangle similarity as well? So if we take a look at these two triangles right here, you will see that just by knowing that only one set of corresponding angles is congruent does not make a triangle similar. Okay, so if you look at angle A, it's 48 degrees. If you look at angle D, it's 48 degrees. But then you can clearly see that F and B would not be the same size, and that C and E would not be the same size. So the corresponding angles, and actually I misspoke, you can see C and F those are corresponding. They are not the same. You can see B and E, those are corresponding. They are not the same angle size, okay, clearly. So what we're going to do is we're going to take a look at some possible shortcuts. And we're going to start off by looking at what happens if we know two sets of congruent angles, if we know two sets of angles are congruent. Okay, so again, we're going to do some of this on Desmos. So we're going to jump over to Desmos, and I've already drawn the triangles for this. So you will see triangle ABC, and then you'll see that I have drawn a second triangle, DEF, with angle D congruent to angle A and E congruent to angle B. So take a look at this. You'll see right here, if I measure these angles, we have angle A should be congruent to angle F, or angle D, and the other one was angle E, right here, should be congruent to angle B. So let's take a look to see if that's true. 90 degrees. And so if we look at this, what do we know about angle C and angle F? Angle C and angle F both have to be the same size, because the triangle sum conjecture says that the angles of a triangle add up to 180. So you have 45 and 90. This means that angle C has to be 45. Same thing over here. So what we get here is we see that, okay, if we know that two angles are congruent, we know that the third angle has to be congruent. Now, this doesn't show that they're similar, but if we can check their side lengths, so let's label their sides, 3.61, 7.21, 7.21, 3.61, 10.2, 5.1. So what we're going to do is we're going to compare the ratios of the corresponding sides. So we have, if we look at our notes, we want to look at AB compared to DE. So if we jump back there, AB is 3.61. So 3.61 over DE would be 7.21. And I'll flip back to the notes here in just a second so you can see what I wrote. AC is 5.1. DF is 10.2. And then we have BC, which is 3.61 over 7.21. Okay. And so flipping back to the notes, you'll see that I wrote down these ratios, and this little symbol means that they're approximately the same. So if we take a look at this, we have 3.61 divided by 7.21. That's going to be 0.5006. So we're going to say that is 0.5. So it's approximately 0.5. And then we have 5.1 divided by 10.2. That is 0.5 exactly. So we have 0.5. And that's approximately equal to 3.61 divided by 7.21, which we know is already 0.5 because it's the same as the first one. So what you'll see here is that in this triangle, these two triangles where we had two angles that were the same, it turns out that the ratios of the sides actually were the same as well. So what that tells us is if two angles of one triangle are congruent to two angles of another triangle, then the two angles, or the triangles, are similar. Okay? Again, if you know that two triangles or two angles in one triangle are congruent to two angles of another triangle, then you know that the triangles are similar. Okay? Now, we're going to take a look at our next shortcut. And this time we're going to take a look at what can we say about sides. So if we know all three sets of corresponding sides, okay, if we know all three sets of corresponding sides are proportional, does that make them congruent or similar? So again, what we're going to do is we're going to jump over to Desmos, and what you'll see is I have two triangles, okay, and I've drawn triangle ABC, and then I drew triangle DEF, and I will tell you that triangle DEF, the side lengths are a multiple of the original triangle, and you can see that DEF is a little bigger. Okay, so what we have is we're going to compare the corresponding sides and the corresponding angles. So if you look at this, you can see 4 and 8, 2.24, 4.47. This will be off just a little bit because of the rounding that Desmos does. 6.08, 12.17. You can see that triangle DEF is twice as big as BCA. Okay, so in our example, it is twice as big. Now, for the next part, if we want to look at the angles, because again, just because the sides are proportional does not mean that this is similar necessarily. We need to compare the angles. So if we measure the angles, we have BAC, we have CBA, and we have ACB. In order for these two triangles to be similar, these angles better be the same. So angle D is 17 degrees. Angle F should be 9 degrees. And angle D should be 153 degrees. And so what you see is you had two triangles that started off with three proportional sides. Three sets of corresponding sides that were proportional. And it turns out that the angle measurements for those three angles are congruent. The corresponding angles are congruent. So what we can say is that if the three sides of one triangle are proportional to the three sides of another triangle, then the two triangles are similar. Okay, again, if you look at a triangle and you see that all three sides of one triangle are proportional to the three sides of the second triangle, those two triangles are similar. So at this point, we know that if we have corresponding sides, three sets of corresponding sides that are proportional, then the triangles are similar. If we have two triangles who have two corresponding angles that are congruent, we know that the two triangles are similar. So that means we need to check side angle side, side side angle. So what we're going to do here, I'm just going to jump down here and tell you. We're not going to do the investigation here. Side angle side similarity conjecture is a good conjecture, okay? So what it says is if two sides of one triangle are proportional to two sides of another triangle and the included angles are congruent, then the two triangles are similar. Okay? Again, I'm just going to tell you that this one works. I'm not going to do this one on Desmos. So if you have, if you know two corresponding sides are proportional, and then the angle between those two sides are congruent, then you know the two triangles are similar. So what we're going to do is we're going to take a look at one example here that represents the type of problems that you'll see on your homework. You have two triangles here. Okay, they're connected at point E, so it looks like an hourglass type of thing. So what we want to do is we want to tell why triangle ABE is similar to triangle DCE, and then we want to find the measure of, in this case, side X. So remember, if we want to show that two triangles are similar, there are three things that we can look at. We can look at angle angle, you can look at side side side, you can look at side angle side. Okay? Now, looking at this, we do not have three sides to compare. Okay? We also don't have two sides to compare because we have 8 and 6, we have 4 and X. We don't know what X is, so we can't see if those sides are proportional to determine similarity. So that leaves us with, can we use angle angle to determine if these two triangles are similar? And the answer is yes. We know that line AB, or side AB, is parallel to CD. And because they're parallel, what we know is angle B is congruent to angle C by alternate interior angle theorem. And we also know that angle A is congruent to angle D by the same thing, the alternate interior angle theorem. So why is triangle ABE similar to triangle DCE? It is because angle B is congruent to angle C and angle A is congruent to angle D. So by angle, 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 the triangles are similar. Now, we know that they're similar, so now we want to find X. So if they're similar, that means that the corresponding sides are proportional. So in this example, AE is corresponding to ED, and BE is corresponding to EC. So we're going to write some ratios. So we know that if they're proportional, the two ratios need to be equal. So you have 8 over 4 has to be equal to 6 over X. So I have the big triangle over the little triangle. So you cross multiply. You have 8X equals 24. X equals 3 centimeters. So the length of that side is 3 centimeters. So that being said, you can go ahead and start working on your homework. This should say odd, I believe. Check the homework. It is correct on the box on the homework. And go ahead and start your homework. If you have any questions, message me or email me or ask questions in class.